Okay, hi everyone. So I'm Virginie Gabel. I'm a doctor in neurosciences and chronobiology. So today I'll share some of my research I did during my postdoc. Right now I also have a company where I do occupational risk prevention as a consultant in companies. And I'm also a board member of the Good Light Group, and I coordinate with Marijke Gordijn, the Science Advisor Group. So the topic of today is, can we live without light? Just as a quick reminder, does it work? Yes. So we all live on planet Earth, and that rotates over 24 hours. And we have a light-dark cycle that our body should kind of follow. And that's how we created our circadian rhythm. So that is a rhythm that is approximately 24 hours. How does that work? So everyone has a biological clock in the brain, in the suprachiasmatic nucleus. But this clock doesn't really turn at the 24-hour cycle. And how we found that is in the 60s, there were plenty of different experiments without light. And one of the famous one is with Michel Stiff, which was a French speleologist. He decided to spend 60 days in a cave in the 60s. So it was 100-meter underground. So no, it couldn't see the natural light-dark cycle at all. And he was connected through a kind of a phone with people outside the cave. So what he did is every time he was asleep, he called the people on outside and say, I'm going to sleep. And they try to make a mark here. And then when he wakes up, he calls them again. So they stop the mark. The idea is if our biological clock was turning on a 24-hour cycle, that means that almost every night you would have gone to sleep at the same time and wake up at the same time. So following this line here. However, we found something like that. So we could see that it's still a rhythm because every time, it's not that one time he was asleep here and one time here. We can still see kind of a line here, but every day he went to bed a bit later and every morning he wakes up a bit later. And that's how we figured that our biological clock is not set for 24 hours, but either faster or slower depending on the person. And for him, it was 24.5 hours. So how come we living on Earth, we live on a 24-hour cycle? That's because every morning when we wake up, our eyes catches the daylight. That's something really important because when the eye catches the daylight, then it sends the information to our biological clock so that this clock resets, starts at zero again, so that we live on a 24-hour cycle. And this is important for the body because if you check here, so that's what we call the central clock, and we have several different peripheral clocks. So every morning when we see the lights, it resets the central clock, and this central clock gives the information to the rest of the body saying it's a new day that starts, and all the body is now synchronized through the light. The aim of this is that our internal circadian rhythm is synchronized with the external time giver. So that's how we call the light stronger time giver for the body. If we stop here, that would be really good. So no sleep problem, no problem at all, because we would follow the light-dark cycle. Our body will know when to go to bed, how to eat, when to wake up. But unfortunately, we all have our social life. And all the things that we do during the day can impact our body so that we don't go to bed when it's time to go to bed, or we don't eat when we are hungry, but we eat when it's time to eat. And that will impact our behavior.
Yes, plug it in.
Sorry? Oh, no, okay. So that will impact our behavior, well-being, cognitive performances, alertness, sleepiness, mood, and also our physiology. And we observe more and more of these changes nowadays. And why is that? Is because since industrialization time, people spend more time inside. Almost 90% of our time we spend indoors. And about 25 to 30% of the population complains of clinically relevant sleep problems. We figure that indoor lights are about 50 times lower than a regular outdoor light intensities, and as well as the spectral characteristics of electric light are completely different from natural lights, meaning that we almost live in a biological darkness all day long, leading to mood disturbances, problems with concentrating, difficulties with learning and memory, higher risk of errors and accidents, and health and well-being problems. So knowing that, we wanted to know if we can live without light, without daylight, or without a light-dark cycle. And that's how, what I will try to explain through an experiment that we did to figure out if the social interaction or our social life is enough to synchronize our body. So it was a study organized by the Human Adaptation Institute in Paris. It's a French explorer that organized this study, and we were around 10 scientific teams working on it. And the team I was working with in Caen University, we are focusing on all chronobiology and sleep data. So what happens? It was 14 individuals, so half women and half men, around 35 years old, as they spent 40 days in a cave, around 10 degrees Celsius, 100% humidity, and it was a long cave, so they were not, they could move around. So basically here, they never went, this is the entrance, and they never went further here. So they could never see the light dark cycle. There were several, they had several rooms, a living room, where they could turn on and off a light. They had no clue about time, but when there were 3 or 4 people, they were allowed to turn on these lights. Then they also had a scientific zone where every day they did a lot of different experiments. And the sleeping room where each of them had their own tent. So the light that you see, it's only for pictures, but there were no light at all. The only light was this big sunlight in the living area, and then they have some headlights to walk around the cave. Okay, so what we observed after these 40 days, we checked their cycle. So one cycle for them represents 1 day, meaning a wake period and a sleeping period. And if we check, so this is the number of cycles for each 14 participants, meaning here that these participants calculated 27 days. So every morning when they wake up, we ask them to calculate the day. Even so, everyone spent 40 days in the cave. You can see that some were calculated 27 days, 31 days, 24 days. So 24th day, it's the minimum day we have, and 31 is the maximum. If we check their cycle duration, that's the mean of each one. Meaning that here in blue, that's the 24-hour cycle. And you can see that all people are over 24 hours. If we check the mean of all these 14 participants, this is before entering the cave, and this is when they went outside the cave. So it's approximately 24 hours. Inside the cave, the mean cycle duration is 31.6 hours. Of course, it varies depending on the people, but the mean was still 31.6 hours. If we check more in details, so here you have a graph. This is the cycle duration. So 24-hour cycle is here, and it goes over 72. And here, the length of the white bar is the number of time this cycle duration occurs across all participants and across all 40 days. So for example, if you take 24 hours, you can see it's approximately 16. So it means that a cycle duration of 24 hours occurs 16 times. You can see here, this is the mean that I showed you before, so 31.6. This is a median. And you can see here that there are still some times, so for 1 or 2 participants, that they had a cycle duration of more than 48 hours. One was even 70 hours. We also find a correlation between chronotype and cycle length. So chronotype means that if you're a morning type or an evening type. We know that if our biological clock, our internal clock goes faster, you're more a morning type. If it goes slower, you're more an evening type. And this, we can see this correlation here. So the participants who were more morning type, they had shorter cycle duration. And participants who were more evening type had a longer cycle duration. So next, we try to see here, that's Michel Stiff in his cave. We can see here during the first day, he was a little bit delayed and then a bit more delayed. We wanted to see here if it's the same for our 14 participants. If you don't know, so this is a actimetry. Every time you can see these black bars, that means that they are moving. So basically, if it's really black here, they are moving. If it's almost white, that means that they are resting. We don't know if they are actually sleeping, but at least they are resting. And you can see for almost all participants, the first week, we can see this really nice sleep delay a little bit every day, a little bit later. After a week, this is what occurs for everyone. We don't really see a nice rhythm. We see a little bit, sometimes a long day without any rest, sometimes a long day with rest and without any movement. And we wanted to see if there is a correlation between something, if there is kind of a social synchronization between some people. What we see first is more they spend time inside the cave, the longer the cycle duration is. And we see a correlation between time awake and time asleep, meaning that longer they are awake, longer they are asleep as well. So we check the ratio. We know that in normal life, we have a ratio of 1/3, meaning 1/3 of your time you're asleep and 2/3 of your time you're awake. Basically, it's 8 hours sleep and 16 hours awake. That's what we find for them before entering the cave. And in the cave, yep, we find almost the same, meaning that no matter how long the cycle duration is, they were always 1/3 asleep and 2/3 awake. So you can imagine for the people who had sometimes a 70-hour cycle, they were almost asleep for like 24, 25 hours. Now, okay, we have all these individual results. We wanted to see if there is any kind of social synchronization. So what we did is every time someone was awake, I will show you, okay, here. So this is before entering the cave. The more black it is, the more people are awake. So if it's completely black, that means that the 14 participants are awake at the same time. If it's completely white, that means that the 14 participants are asleep at the same time. So this is what we find outside. they were awake during the day and asleep during the night, and here awake during the day. In the cave, we find again, it's not as black as here because we are missing 2 participants before entering the cave, that's why. The first week inside the cave, we can see as well, as you could see before, that everyone was almost asleep at the same time and awake at the same time, but every day a little bit later, and every morning a little bit later as well. And after a week, that's what we found. So there was no real social synchronization. They were all over the place. And after we asked them, and some people said that for several days, they didn't even see each other because when one was going to bed, the other one was waking up. And there is not real social synchronization. I didn't show it here, but we tried to did some of subgroups, and we could see that morning people had a better kind of a social synchronization, and evening people as well. And that's usually because their biological clock runs at the same time, and so they were going to bed at the same time and waking up at the same time. And then when they went outside the cave, it took only 2-3 days to synchronize again with the sun. And you can see again that they were almost all asleep at the same time and awake at the same time. So the conclusion is that with our regular light exposure, we can't really live on a 24-hour cycle, that the subjects prefer to follow their own internal rhythm over following a social synchronization when isolated from external time giver. And here as well, we asked them about their sleepiness, their alertness, and everyone was fully alert and almost never asleep or sleepy, because when they were asleep, they went to bed. And when they were completely rested, then they woke up. And the social interaction is not strong enough to synchronize the body. So coming back to the last slide, so why this change? So the solution to not live in a complete darkness, here I take my good light hat, is to spend as much time as possible outside, use good light indoors, because we know that a good light has a similar beneficial effects as natural light on the body, and you'll be more synchronized to our 24-hour Earth rotation. And I'm done, and I'm okay for question if you have any.
Hi, Virginie. Thank you very much for excellent and insightful presentation. Wow. Yeah. So how much proof do you need more than this, that light is relevant for people's health and well-being and sleep? Are there questions by the participants?
Yes, I raised my hand.
Okay, yeah, I see that. Yeah, thanks.
Yeah, wonderful data, Virginie. Of course, I knew the experiment was running, but I never saw the data. So wonderful. I was wondering whether you probably did. Have you measured how much light they were exposed to in the living room? So in the room where they could turn on the light, because the periods are the endogenous periods are quite long, right?
Yeah.
And we have seen from certain protocols that on average free running rhythms seem to be 24.2 hours. So can the relatively long endogenous periods be explained by by the light exposure they were exposed to in the living room?
Yeah, sure. There is several bias for the results. One is the light, because of course they had no idea how to, what time it was, so they could turn it on and off whenever. And it was, if you were just like near the light, it was 350 lux, I think. Real measurement, like good measurement, hasn't been done during the experiments. We did it afterwards, but yeah, it was still a strong light. So
Yeah.
of course it can a bit delayed. And the other bias that might be is that during their time there, they had some work to do, like they tried to grow some plants. They had to explore the cave to make a 3D map of the cave. And some people were waiting that their friends wake up to do this together. So this could also a little bit delay their sleep timing for some days.
Mm-hmm. Yeah.
Okay.
And
Thank you,
if I can
Virginie.
just, sorry, I can
Yeah.
just add something is we know about this 24 point something hours for the cycle duration, but we thought that maybe the temperature will show that. And we could see that the temperature was almost following their sleep cycle duration as well. So we also have a longer temperature cycle.
Okay.
Yeah.
Okay.
There,
Thank you.
there are three more hands that I see.
Yeah.
Let's cover those. Domitil.
Yes, thank you, Virginie, for the presentation. I just have a quick question. Was food intake measured? I mean, quantitatively and qualitatively for participants?
We tried to. We had a questionnaire about that, and usually they add the 3 meals, so breakfast, lunch, and dinner. But the thing is, because they were all awake at different timing, there was always someone eating, and people told us that even though they had 3 meals, but every time they were snacking because there were food all the time. And so we don't really have a real checking or like, logs for food.
Okay, thank you.
Okay, thank you. Torben, you also raise your hand.
Hi there. Well, fantastic presentation. I saw the results on sleep duration before, during, and after, and it's just struck me that the after seemed to be so very much closer to during than before. So
the ratio, you mean, right?
Sorry?
You're speaking about the ratio?
No, the sleep duration. You presented a slide where down in the left corner there was sleep duration 6.8, 8.8, and 8.4 respectively there.
Okay. Yeah, no.
No.
Because I have the ratio, so I don't know if you're talking about that.
There we go. Oh, that was the sleep ratio. Sorry for that.
That's the ratio, yes.
But how can so what my question is, coming out of the cave, did they learn anything from sleeping in as free running as they sort of intrinsically wanted? Did they change their sleep behavior once they came out of the caves?
Yes, so some of them. The thing is that post-cave is 2 weeks later, like from the exit of the cave, and 2 weeks later, and some took like a week to recover. So they were sleeping a bit longer when they came outside. That's why the ratio is still a bit high compared to just before. We haven't done it 6 months later to see if the ratio came back to before. But we know that some of them realize that listen to their body is really important, and they try to stick to that and to listen and to have a better sleep and to organize their day so that they could sleep better.
Okay, so a bit of education.
Okay. A little bit. I don't know how long it takes, if they are still doing it or not. But yeah, for the first months they try to do that.
Interesting. Thank you.
Okay, yeah. Let's go to the last question from Jürgen Hedrich.
Yes, again, thank you for an excellent presentation. I really enjoyed it. So important knowledge. I have actually 2 questions. So first of all, like the end of the presentation, you mentioned kind of like good light is so important, especially because we spent 90% of time indoor. So what is exactly the good light? I mean, what is exactly the color temperature, like perfect color temperature? What exactly the perfect spectral distribution, etc.? How would that light source look like?
So the best light is daylight, of course.
Yes, I got that.
Yeah, and it depends on color temperature and intensity as well. So there is a nice table in the good lights group. It's not a program. Help me.
Light guides. Yeah.
Thank you. Yeah. So what is recommended is in the morning. It's 250 medilux, so it's a bit different than the lux that we are used to work with. Medilux is how the light impacts your biological rhythm. So if it's 250 medilux on your eye level, that means it's about 1,000 lux. The one that you're used to horizontally, yes, with
okay, got it. It's like vertical instead of like horizontal measurements. Yeah. Okay. And about spectral distribution or any like, is it possible to sort of like really specify like this perfect artificial light source? Or
yeah, so in your eyes you have specific cells like ganglion cells. I didn't talk about it at all, but you have specific ganglion cells that are that will give the information to your biological clock. And these ganglion cells are specifically activated with 380 nanometers.
Okay.
Yeah, a little bit more on the blue side of the spectrum.
Yeah.
Yeah.
All right.